السلام عليكم ورحمة الله تعالى وبركاته. أعتقد أن الصوت واضح الآن. هكذا كي نبدأ على بركة الله. جيد. معكم عليان عبد النور جي تيزي وزو من الجزائر. دورة اليوم بإذن الله ستتناول موضوع Site Reliability Engineering، وهو موضوع شيق. الموضوع يتكلم كثيرا عن أصحاب المؤسسات، ليس فقط فيما يخص البرمجة، لكن نحن سنتطرق أيضا إلى البرمجة. السيشن ستكون بالإنجليزي، هناك دورات أخرى بالعربي، ستكون بإذن الله هناك دورات عن Site Reliability Engineering بالعربي. لهذا أنصحكم بتفقد القناة، ففيها العديد من الدورات منذ شهر جويلية، وسيكون بإذن الله دورات أخرى. يمكنكم أن تحصلوا على السيرتيفيكيت، على شهادات المشاركة، والمهم أن تتعلموا معنا. الآن سأقوم بالتحدث بالإنجليزي. أتمنى أن يكون الموضوع مفهوم من طرف الجميع، وإذا كانت لديكم أي أسئلة يمكنكم طرحها، وبإذن الله سنكون هنا للإجابة على استفساراتكم. Welcome everybody. الزلف الأول. Today we are going to talk about the Site Reliability Engineering. This session is not only for people who want to program. This session is about entrepreneurship and how to deal with your startup or with your team. Why I choose this topic? Because simply there is a problem when people program. They do programs, but they do programs and codes, but not product. The problem is that people try to understand what is Docker, what is Java, what is Python, but they forget the most important, which is the product. When you sell something, you are going to sell products, not codes. When you go to Google Play, you are not going to download the source code. You are going to download a real application, a product where there are many people behind, not only programmers. There is a team. Even if you are a freelancer, you need to understand those concepts. So the first thing you need to understand is that you need to sell products, not codes. This is the first rule. The second rule, you need to respect your coworkers' efforts and your client's expectation. The first, your clients need something useful, and he needs something reliable. And your coworkers must not be slaves. They must work with you, not work for you. And this is the key to make money. Because if your coworkers are happy, you will gain money. That's easy. So today, bi'idhnillah, we will discover those rules who make your startup a good startup. So, before we talk about SRE, we need to talk about DevOps. I think in the descriptions, in the description, if you read it, you will find the word DevOps. And the DevOps is the word that you will hear a lot, especially with the cloud computing. You will hear a lot about DevOps. So the first thing I need you to understand, DevOps is not a job. DevOps is not a tool. DevOps is a mindset. So the word DevOps is a split between developer and operation. Notice that the dev from the developer and the op from operation. So the developer generally he writes codes, test and design new features, while the operator manage the hardware, manage the servers, checks the bandwidth, and manage the security. For example, the pen testing, and tries to update the system and so on. So that's the meaning of the DevOps. Why the DevOps? This is to break this gap. Because if there is a gap between those two people, we will have a lot of problems. So the DevOps is a mindset how to make the developer and the operator work together. And we will not stop between those two people. We will expand it to all the people in the startup or in your enterprise. We will see that later. Here is the operator, and here is a programmer. So you need to know that in the past there were no USB disk, no hard disk like we know. There were tapes. So the programmer, when he programs something, he needs an operator to do all this stuff. That's why we call them operators. But now with the evolution, the operator don't do that. He do the stuff that we know. He checks about the operating system. But the problem is that in the future with the cloud, he needs new practices. And we will see all that today. So for people coming from Python, I promised you to not use code, but we need just this. Don't worry about this. So the code is that if we define the DevOps as a class, the DevOps, we need a method to break the wall between the developer and the operator. So to do this, we need to think. So it's a mindset. It's not a tool. Why I say this and I insist about this, because you will find people who will be like, oh, I'm a DevOps. There is no job about DevOps. To be a DevOps, you need a lot of things. This is not because you know how to do script shell or how to do Python that means that you are a DevOps, or because you know how to do continuous integration and deployment that means that you are a DevOps. A DevOps is a mindset. So because it's a mindset, we will see how it works. But before we see how it works, why do we need a DevOps? Let's check this report. It's a 2090 reports about what can do a DevOps for your enterprise. So they made, they classified the tasks. So they made the deployment frequency, the lead time for change, time to restore service, and the change failure rate. For example, you have a website, the website went down. So how are you going to restore it? Because time is money. So they split the time on 4 categories: elite, high, medium, and low. The elite, they measure what they gained when they did the DevOps mindset, and here is what they get. They got 208 times more frequent code deployment, which means that you keep updating your software. You keep making it better and better. You have 106 times faster lead time from commit to deploy, because when you do continuous integration, you need a delivery. So the DevOps will teach you how to go from integration to deployment. More than 2,600 times faster time to recover from incident, which means that if you have a crash, the DevOps mindset will help you how to recover. And 7 times lower change failure rate. That means that next time you will avoid another fail. You will learn from your experience. And to resume the DevOps mindset, we can use the word CALMS. CALMS stands for culture, automation, lean, metrics, and sharing. And that's what we will discover in this session. We will go through them one by one, so don't worry. Just relax. The first one we need to understand is the lean. The lean is like, imagine that you want to eat something. So the lean is just you eat without waste. You just eat what you want. So only what you need. The philosophy behind lean is to eliminate the waste. Why? Because we need time. We need faster time. We need to time to market. The time to market is the time between producing something and shipping it to make it available for customers. So this is what we call the time to market. If we got something, we need a product, and this product we need to sell it to someone. So what kind of waste we can have? We have a lot of types of waste. We have a knowledge waste, waiting waste, over processing or over production waste, motion waste, transportation waste, correction waste, inventory waste. The lean mindset tries to teach us how to avoid those kind of wastes. To understand how lean exists, let's go to Japan. And in Japan, we need to go back in time and see how Toyota made it and became what we know today. So let's go back in the history. So everyone knows that Japan has passed over a nuclear war where it was erased. So there were no resources, there were no money, and it started from zero. It crashed in the term of computer industry. So one guy decided to help his economy. So he went to USA. He went to General Motors to see how they produced cars. So he started to check how it works because he wanted to go back to his country and save his country. He saw in General Motors that they produced cars, but there was a problem, is that they have money, they have resources, and they produced more than what people need, which means that if you produce, for example, 1,000 cars, people buy 100 cars, you have a problem with 900 cars. What are you going to do with them? It's a waste. So he went then to self-service shopping, and then he noticed the concept of shop by yourself. It's like you go to the mall and then you buy only what you need. You don't buy something you don't need. So he combined what he learned from General Motors plus what he learned as a person when he was buying things in a self-service mall, and he created the lean. The lean is to focus on customer value, what a customer wants, because you need to inverse the processes. The process in General Motors is produce and then sell. But in Toyota, they decided to bring the customer, ask him what he wants, and then make something for the customer. So you don't get a waste. Eliminating the waste and one piece flow, which means that every department must do only one thing. He should not do something that he is not made for. And because you have every department should make something, there must be synchronization between those departments. And that's the shared and continuous learning. What happens in Toyota is that every time there is something wrong, they stop everything. And then he called everyone and he asked them to learn. They tell them, okay, watch and learn. So because everyone was watching in that bug or that problem, the next time that will happen, it will not happen because they will know how to avoid it. And that's the shared of continuous learning. And this will lead to eliminating the overburden of people because you split everything. Someone will not feel the pressure because he knows that there is someone else who can do a good job. So when he gets in the production, he will get something that was made by someone which is good. So it's like a chain, a production chain. By the way, I'm sorry for my English because I'm Amazigh. I speak Kabyle, and then I speak Arabic, and then I speak French, and then I speak English, which is at the fourth level. So I try to do my best. I'm evolving. So because you eliminate the overburden of people, you need to get where is the bottleneck and where is the constraint. And that's what we call the theory of constraints. The theory of constraints is that you try to isolate the constraint and work on it until you solve it without affecting the chain. So this is the lean, and this is what made Toyota the best from the best, starting from zero. And that's what we try to do in the DevOps. In the DevOps, we try to apply the lean. So people coming from computer industry, they know what is agile, they know what is Kanban and Scrum. There are many sessions in the channel. You can check them. They are in Arabic. You can learn a lot from this. And because we are a team, here is an example. Let's check this printer. Imagine that this printer is good, but this one is bad. He needs to have this thing to start running. So if there is a problem with this one, this runner, even if he is the best one, he will have a problem. And that's the work of the team. Everyone must be good. He doesn't need to be perfect. He just needs to be good. Because if he is good, he will make his colleague better. And that's an example in programming. Imagine you are a programmer and you keep programming day and night. You get depressed, you get stressed, and then in the other hand, there is another department who works slowly, and because there is no synchronization between you and this department, the boss gets really angry and the client doesn't get served. So we need to have the same page from the developer and the operation and the validation or quality assurance or whatever you call it to make the good product and to make Mr. Kitty happy. And there is another problem. Even if you are a small startup, you will say, hey, I'm not that big startup where I have a lot of departments. I'm just a small startup with 3 or 4 people, but you are working on the cloud. And in the cloud, you have services. So the services, you need to see them like people working with each other. So those services, if one crash or if one get like a lag, it will affect other services. And here we are, the SRE. The SRE, if you notice, this is the infinite sign. That's the same like the DevOps. By the way, there is no official logo. I just found it on Google Image. I hope uh, there will be an official sign logo. So this logo, that's infinity, which means that not only you have the infinity, but you have like a recursive. You do something and then you evolve. So as we defined the DevOps, we define the SRE. The SRE, what is the SRE? The SRE, as it defined at Google, this is what happens when you ask a software engineer to design an operation team. This is like breaking the wall between the software engineer and the operation team. So instead of being a businessman, a CEO, because you have a startup, instead of being bored and sitting and waiting to your enterprise to do gain, you need to work with them because you need to be a leader. So a leader, I think you have already seen this wonderful picture. You don't need to be a boss. You need to be a leader. You need to help your coworkers to make the mission move. So with SRE, you will have this. So you are not the boss. You are the leader. So with the SRE, you will find a way to make less effort and to be more productive. And here is the concept of the SRE. The SRE, as I said in the beginning of the presentation, I said don't focus on the code. Why? Because the code, as you see, it's here. People keep seeing the development as everything, while it's not everything. Look, we have the monitoring, the incident response, we have the postmortem, we have the testing, we have the capacity planning, and then we have the development, and then we have finally the product. There is a good concept about this. They say that you need to check your product like a woman when she is pregnant. When she is pregnant, the most important is the baby. Of course, the woman is important, but if we see the time, it's not the 9 month or the 8 month that are important. It's what comes after she gives birth. And that's the concept of the product, because you need to update it. You don't develop your product and then throw it. You need to update it. You need to keep it. This is not only I code and then I throw my code and then I don't care. No, things don't work like this. You need to see what you do as a product. So as we defined the DevOps as a method between about breaking the wall between the developer and the operator, and then we said you need to think, and SRE you need to do. So SRE defines how explicitly we do things to make DevOps, because DevOps is a mindset. In SRE it shows how to do things. So let's go back to our Calm's DevOps principles, and then we will see how to apply those concepts. So the first concept, notice that I will not respect the order. The order is just to form the word Calm's. You don't need to respect the orders. So the first one, sharing. And sharing is caring. What we are doing right now, I'm trying to share with you those concepts, then you will share this to another one and so on. That makes the thing evolve. So sharing is caring. You need to reduce the silos in your enterprise. What is a silo? This is a silo. If you go to the industry, you will find those things. Everyone is called a silo because every place is made to do one thing, and then there is a production, and then we try to merge everything. And this is what happens when you are in IT. Those are the IT silos. So that's why you keep hearing about open spaces, because when you have open spaces, imagine this guy has a problem and then there is something closed here. He will not learn from this. He needs something open to share the knowledge between each other. So why there is separation here? Because in computer industry, you need some privacy too. You can't work in a complete open space because there is noise, you need to think, you need to solve problems. So you need some open, relatively open spaces, not completely open spaces. And by the way, Google uses the garage mindset. So you need a place where you are there, where you need to code, because there is no one who blames you there. That's where we are going now. And remember, at the college or at school, when we do the practical work, the teacher explains while the students are with the teacher. There is no isolation between them. That makes everyone learn. And when there is a student that has a question, he can ask the question. And when he asks the question, the other ones will learn with him. So this is the first mindset. This is sharing. And because we are programming, we need a centralized remote repository. A repository is a place like Google Play where you go and download your code. So download your application. So in programming, we have what we call the version control, where we go to some place and bring the latest version of a code. and then someone else can validate it, or he just check about it. That makes us work together and learn together and discuss our code. And we need to document our code. So it, no one can know the utility of something. What we do by nature is try to use what we have in the best way we see them. So we need to document the maximum about the tools. And here is a joke. I remember the first time I saw this joke. You can find them a lot in internet. The boss, he asked them to give him some ideas, and then there was a guy who is sarcastic. He told them the real solution. So they threw him. This is not how SRE works. SRE works like this. So if you say something, you get rewarded. So I know there are a lot of introverts in the computer domain, where when you are introvert by nature, you are not you don't talk a lot. So try to make uh, try to make an effort. Don't worry, you are in work, so you don't wait for other people to blame you. Just talk. Every idea is good, because that's what you do. You try to propose something. Oh, maybe you will be someone who is better than others just because you gave them the right idea. And then the day after, she can be the best. And then he will be the best, and so on. That's what we do. We need to share our idea. Don't leave it in your head. Make it out. So, the second one, the metrics. We saw share everything. Now measure everything. If we go back to the concepts of SRE, look at the base. It's the monitoring. This is not coding. This is monitoring. You need to record everything. You need the data. There will be another session about the importance of data. You need the data, because by the data, you can decide what to do next. You need to see and to record everything to decide about your next move. So, by the way, this is like a Maslow pyramid, where the basic needs are here. So the basic need of the SRE is monitoring. You need to monitor. So monitoring, they can be alerts, they can be tickets, and they can be just logins. So alerts, you need to take the action right now. The tickets, take the action, but not immediately. And the login, you need to record it, and then you need to check on it if you need something. And there are two types of monitoring. You have the white box and the black box. The white box is checking about the HTTP log, the database log, if there is a crash. And then black box is checking what happens with your box inside. RAM usage, the disk usage, the operating system information. And then you are not going to study all the metrics. You are just going to study the most important metrics to make your decision. So the most important metrics, as an example, you have the latency, you have the traffic, and you have the errors and the saturation. Those are the metrics, the most important metrics we use in the computer industry. And then we have the unplanned downtime. So when you check about the logs, sometimes you will find that there were a crash. So why we call it unplanned? Why we just say downtime? Because sometimes you need to provoke a downtime to make, for example, maintenance, service maintenance. You need to shut down your service for example, for 1 minute or 2 minutes. But an unplanned downtime is where that shutdown happens without you expect it. So let's see this as an example. We are here, we are connecting to a server, which is YouTube, for example, and we are sharing, we are sending data and receiving data. So if we measure the availability of our service, we do the uptime and we divide it on the uptime plus the downtime, which is the total time of, for example, 24 hours. So the uptime, if we have, for example, 11 hours by a day, we do the 11 divided on 24, and then we get, for example, 40% of availability. But we have a problem. Sorry. Now that we are in the cloud, we cannot measure this, because imagine this server shuts down. How we are going to measure the uptime? There is a solution. We just check about the successful requests, and we divide it on failed requests. Sorry, I inverted. I must revert this. It is the failed request divided on successful requests, so we can find how much failure we have. Can we have 100%? Absolutely not. Why? Let's check this. In the industry, what we find generally is those 90%, 95%, 99%, and that's what we called the number of nines. So here, for example, we have three nines and a half. That's what you will hear in the future, especially in the cloud. The four nines, the five nines. So notice that there is no 100. We can't have perfection. So when you say, for example, our service is available 99.939%, that means that by year we can tolerate 8.76 hours downtime, and by hour we need 3.6 seconds. If we have 4 seconds of crash or downtime, we don't have 99.9. We have something like 99.5. And that's what we will see to measure our reliability. So, what is a reliability? We strive to make a service reliable enough, but no more reliable than it needs to be. Which means that if you have something that you saw that 95% your customers are happy with it, don't try to make it 99.9, because you will have to pay money for this investment. So you need just to invest about what is good for your customers and what is good for you. And this is reliability. Don't make it perfect. Start with the strict minimum and then try to grow. And that's what we saw earlier with the lean philosophy. And to do this, we need those concepts called SLO, SLI, and SLA. So the SLI are the metrics. We saw earlier about the metrics. Those metrics, those are called SLI. So when we hear SLI, those are the metrics. The SLO is the objective. For example, if we have a traffic, for example, a latency of 50 seconds, we want to have to achieve those 50 seconds. The SLO is the objective. We need an objective of 50 seconds. So let's go back to our slide. SLO is the service level objective. This is the SLI we want to have. For example, I sell you a phone and then I tell you, look, this holds, for example, 6 hours in battery. So the SLA is, for example, is the value you are going to take about the battery usage. The SLO is 6 hours. If it takes 5 hours, then we need to sign an SLA, an agreement. So the SLA is a contract in case you don't have the SLO that I promised you, then I will give you your money back. Or there is another solution we need to discuss in the agreement. So the SLO is the objective. The SLA is that value we aim in the SLO. And the SLA is the contract. And then we have the error budget. The error budget is how much we are going to tolerate. So if we take 90% as an SLO, the error budget is 10%, which means that if we have 90% availability, we need to have 10% not available. And not available is the error budget. So how we are going to use those three concepts? It's an iterative way. We measure, remember, SRE is based on monitoring, we measure, and then we try to improve. So we check the step two, we compare the SLA to the SLO. The SLA, the values to the SLO. For example, I have my phone, it is supposed to take 8 hours of battery, but it took 7 hours. There is a problem. And here I need to take an action. So why did I say 90% is better than 19.99? Here is the story about YouTube. So Google, when they bought YouTube, I will read it clearly. In 2006, YouTube was focused on consumers and was in a very different phase of its business life cycle than Google was in time. Google, they started using Google search and then they bought YouTube. So the Google search, it was already mature. It needs, like, if I type something, I need to have the answer. But in YouTube, at that time, I can wait because the connection was not that good. It was on dial-up and so on. So we set a lower availability target for YouTube than for our enterprise, which is Gmail and Google, because rapid feature development was correspondingly more important. What does this mean? That means that if you have 90% of SLO, that gives you a room for improvement. You can scale, but if you have a 99.99, you have to know that you are in a stage of your product where you are mature enough that you cannot update it anymore, which means that you are in the summum. You cannot go higher. You reached the summum of your product. But if you are growing, the best SLO you can have is 19%, for example, and then you improve your product. And by improving your product, you will improve your SLO with time. So the next culture concept is culture, because we are humans. We are not robots. The SRE is based from the doctors, because they are in hospitals. There is much pressure. There are lives of people between their hands, so they need to work in a condition that they make them work again and again. So before the incident, what you need to take the history of the outage. You need to ask big, what means that you need to suppose everything. And then you say, what if this goes down? And then you need to be the white hat. White hat are those people who try to break the system. They are not black hats. Black hats are the pirates. The white hats are people who try to break the system to repair it. So better to break it yourself than someone else. And then in Google, they use what is called the wheel of misfortune. So they choose one in the team and then make him feel the charge of crash simulation. So next time, if there is a real crash, he will be ready. And don't live in theory, make it practice. Don't make things happen in your head, make them happen. And how about the code? You need to follow the Unix directive. Everything we are talking now is before the crash. So your code, you have to avoid dead code. You throw away the bad code. If you see a code which is bad, throw it away. Don't comment your code in production. Remove the comments. Don't flag your code useless. And you have the software bloat. Sorry. The software bloat is that you need to grow your software gradually. Don't make it complicated, because the more complicated, the harder it will be to maintain. And then how Google do this? How Google try to make people feel safe at work? So they hire 50% people, and then they gave them 50% of SRE of their time. Why? Because when they feel pressure, they can be helped, or they can be resent to someone else. And then the worker must adopt the blame-free and post-mortem culture. So the blamelessness and psychological safety is that you need to avoid this. If someone crashed something, don't put your finger on him and tell him you are the one who did the mistake. You are the one who did the mistake because you are blaming someone. So don't blame it. Just make it work. And if it happens, this is fine. But that does not mean that because this is fine, you leave the house burn. Because fire, it will not come at you and say, okay, sorry, and then I will go. You need to take actions. And those actions are what we call postmortems. So you need to be blamelessness. You don't blame other people, and then you need to take action. And to take action, you need to know that there are important values who decide about your reliability, which are the mean time of failure, how much time it took this failure, and the mean time to repair, how much time it took to recover. And a postmortem can be a written record, its impact, its action, the route, and following up, what can I do if it happens? Because things don't get solved just by clicking. You don't resolve the problem just by sitting and clicking. You need to take real actions. So to manage the incidents, you need first to record everything, remember, login, and then you need to trust and intercepts. What that means, in the beginning of the session, we talked about Toyota, where everyone was in charge about only one thing, not two things. So, and if there is something which is affected to someone, don't go take his task. Help him, but don't take the task. Everyone is responsible about one task. And prepare a live incident state document. Make a document where you are going to share it with other colleagues, where you are going to write what happens and the possible uh, solution that you propose. And then if you work, for example, from 8 to 4, and then you are going home, you need to go to the team and then tell them, here is the guy who will replace me. Don't just go and pretend that everyone knows who replaced you. You need to be explicit. And at last, we need to automate everything. Be lazy, but be productive. And that's what we call by eliminating the toil. So by definition, the work of reducing toil and scaling up service is the engineering. That's the real concept of engineer, is how to automate things. And Google use that concept when they hire someone. So what they do, they hire the team. The half of the team are the Google software engineering, and the other half are people who have some skills plus Unix system internets and networks. Why do they do this? Because they know that with time they get bored and they will try to automate it. And that's the engineering. That's the mindset of engineering. What do the engineering is that when he sees himself doing the same task again and again and again, he will try to make it automate, to make himself free. And of course, he needs the skill to make a new tool to not depend on other the third-party tools. And the toil, it can be a manual task, a repetitive task, automatable task, no enduring value, which means that if you do something that is by hand and there is no value gained, that means that that's a toil. And the toil can be something that the more it grows, the more it needs energy. And you need to find a way how to avoid a lot of energy for that task. Why we need the toil? Because it's dangerous. It makes your career stagnant, which means that you feel like you are frozen in time. You don't move. You do the same thing manually again and again. There is no evolution. There is burnouts. It makes your team blocked, and you are an engineer. You are here to automate things. And if you don't do that, you are punishing the whole team because it's a production. It's like chain. Everyone needs to send a job for someone else, and everyone needs to make it good. Here is an example. The Knight Capital, they crashed their system. They lost more than 440 millions in 30 minutes. How that happens? Simply, they tried to correct a bug. There were, I think, 8 servers. So they replicated an update in 7 servers, but the 8th one, there were no updates. So what happens? There were a crash in the 8th server who replicated the bug to the other 7 servers to make the Knight Capital sells the actions with less money, what made them lost more than 400 millions dollars in 30 minutes, 440 millions. And that's what we need. We need to find a way how to automate things. Why I said this? Because that doesn't mean if you automated this, do it blindly. You need to control even how you are going to automate it. So 70% from the outage are due to change in live system. For example, you have Facebook, it works, and then I try to update it while it's working, and I don't control how I update it, there will be a crash. And to do this, to avoid those crash, we need some strategies. For example, the blue-green, where I have the old version, I put it in a server and I call it blue. And then the new version, I call it green. And then I roll back to blue in case of crash. It will not take time. Or I will use the canary, where I have a new version. I will put only few people. The old version, I leave them in the old server, and then I will try to roll them to the new version gradually. And you need to forecast. Forecasting is like the weather. We call it forecast because we try to predict if there is a sun or if it will be rainy tomorrow. So that's the same thing. You need to forecast your service. If I have 2 servers in holidays, do I need 12 servers or I need to grow to 4 servers? That's the capacity. So in cloud, you have this concept with the managed service. For example, in GCP, you have many services that offer you this. They grow with your capacity, and then they go back to scale down when there are not lot of users. And finally, let's see the tools. Since the beginning, I was only talking about theory, just to make you think that DevOps or SRE, it's not a tool. It's not something that you download. It's a mindset. So the DevOps tools, what you need now as a tools, you will see that there are many tools. You need the planning softwares. For example, Trello or Google Keep, because you need to plan how things will work. And you need the issue tracking. We use Jira. We need the source control, Git or GitHub or Cloud Source Repository on GCP. We need building tools like Gradle. For people you working on using Android, they know it because Gradle is not for Android. It's a build tool. Or for example, you need a cloud build on GCP, and you need to test what you already built using, for example, Selenium or Jasmine for people using JavaScript. You need for continuous integration and continuous delivery, CI/CD. And that's the point where I insist about DevOps. DevOps is not only this. Look, there are other things. So to do continuous integration, you need Jenkins. And to do continuous delivery, you need Spinnaker. Or you can do everything using Jenkins, which is fully compatible with on GCP. You need configuration management, Terraform and Cloud Deployment Manager. What is this? This is simply what the operator will do in the next generation era. In the past, you have a server, you have a physical server. When it crashes, you need a backup, you need a lot of stuff. But now your server is no more physical, it's in the cloud. You need the tool to recover this server fast. So the tool that we use Terraform for the multi-cloud, or if you are on GCP, you can use the Cloud Deployment Manager. And then we need to learn how that cloud platform works. If we are in GCP, we need to understand how GCP works. And then we need API management tools because we are using microservices, for example, APG or cloud endpoints on GCP. And then, of course, we need monitoring and logging tools and profiling tools. And the most known on GCP is Stackdriver, which is now called Google Cloud Operations Suite. Or if you are using a black box monitoring, you can use Nagios. If you are using a white box outside of GCP, you can use ELK for Elasticsearch, Logstash, and Kibana, or use Prometheus. Those are the tools. And you have the tool of the knowledge sharing and the communication. You can use Slack, you can use Google Docs to share the documents. And look, all those are the tools to become a DevOps or an SRE, plus the mindset. So next time when you see someone asking to hire a DevOps, go and search about all this and then change the mindset to help your colleague, to be open mind, to be blamelessness, to not blame your colleagues, and then we can call this an SRE or a DevOps. And if you want to read more books, you can read about DevOps, about the Phoenix projects, about the DevOps, or come to this link and get those 3 wonderful books for free. So why did I put those 2? This book made a big revolution about DevOps. Those books, especially this one, they made a revolution about SRE. So in this book, if you read it, it's free online. The 3 are free. You will see how Google managed to use the SRE to scale, to avoid crash, and to be what we know today. Thank you very much. I hope I was clear. I hope my language was understood, and I hope you got a lot of information. The slide is free. You can check on this link and then have the slide, modify it, or share it with other people. The most important is sharing is caring. Thank you very much. See you next session. Let me check if there are questions. There are still 10 minutes or 6 minutes. Okay. Thank you very much. Certificate. I think, I hope you enjoyed this session. There will be other session. Bismillah. Thank you very much and see you soon. And especially take care of yourself. That's the most important, especially in the pandemic period. Thank you very much and see you soon.